Now we are going to talk about the effect of the intensity of light on photoelectric current. Now we are going to see how the photoelectric current increases when the intensity of the incident light is increased. Two terms are there. First, intensity of light, the second one is photoelectric current. If you increase the intensity of the incident light on the photosensitive material, automatically the photoelectric current also increases. Now we are going to see the relationship between the intensity of the incident light and photoelectric current. First we will learn about the meaning of the intensity. Here I have drawn two light beams. The first one is called less intense light. The another one is called more intense light. Actually, what is the meaning of less intense light? Dull light is called less intense light. The bright light is called more intense light. Here, if you go deeper into the less intense light, how the less intense light is made up of, look at that. Here, the photons, number of photons which are present within the less intense light is less. If less number of photons are traveling in a particular space, that one will cause the less intense light. If more intense light means, here more number of photons, light particle, they have to travel together, that one will be comprising the bright light or more intense light. Here we are going to vary the intensity of the incident beam of light on the photosensitive material. Already I have told about the cathode and anode. This is called as cathode. On the surface of the cathode, any photosensitive material must be coated. So let us imagine here sodium is coated. Are you clear? Sodium or calcium or potassium, any alkali metal that could be coated here. Here two things must be kept constant. One is that accelerating potential. Let us imagine 10 volt is supplied across the cathode and anode. This is a cathode, this one is the anode. Across the cathode and anode 10 volt is applied. This accelerating potential should not be altered, and the frequency of the incident light also should not be altered. Let us imagine the violet beam of light, the violet colored light that is made to incident on the cathode. Now we will observe exactly what happens. Now through the mica window, here what we are going to do now, here the less intense violet beam of light, it is made to incident on the photosensitive material. Less intensity light means less number of photons, they are made to incident on the photosensitive material. As soon as it is made to incident on the photosensitive material, very few number of electrons will be ejected out. So they are all photoelectrons, very less number of electrons are emitted because intensity of the incident light is less. Therefore, the number of photoelectrons which are emitted from the cathode will also be very less. When all the electrons they are reaching the anode, that one will flow, that electron they will start to flow in this direction, and the conventional current, photoelectric current, that can be measured here. So here let us imagine 2 microampere is amount of current is shown in the micrometer. So less intensity, less amount of current. Now what I am going to do now, I am going to increase the intensity of the incident light. When the intensity of the incident light is increased, the frequency of the incident light should not be altered. The accelerating potential which is given across the cathode and anode should not be altered. Same frequency of the incident light must be used, but the intensity alone is increased. Look at that. You can see the difference in between the shade of the first one and the second one. Here the shade is less, shade is dull. Here shade is more. It shows that the intensity of the second case, the intensity of the incident light in the second case is more. When the intensity is more, what it shows, the number of photons when they are made to incident on the metal surface is more. When more number of photons are incident, the intensity of the incident light will also be more. Now what will happen now? More number of electrons will be ejected out from the metal surface compared to the first case. So here just 3 electrons are ejected out. Here let us imagine 5 electrons are ejected out. Okay. So for number of photoelectrons ejected out from the metal surface will also be more. When they are reaching the anode, the strength of the photoelectric current will also be more. Let us imagine the photoelectric current measured in the microammeter is 5 microampere. Intensity of the incident light is more, photoelectric current value is also more. Are you clear? Now we are going to see the third case. Again, I am not going to change the accelerating potential and the frequency of the incident light. Now I am going to change the intensity of the incident light. Compared to this shade is still darker and the brightness of the shading is more. It shows that the intensity of the incident light is more. Are you clear? When intensity is increased, what will happen? So here more and more number of electrons will be ejected out from the metal surface. Compared to the previous case, more number of electrons will be ejected out. Are you clear? So due to the emission of more number of photoelectrons, here the strength of the photoelectric current will also be more. Let us imagine 7 microampere is shown in the micrometer. Are you clear? We will see one more case. Now the strength of the, that is intensity of the incident beam of light is still it is more. Are you clear? Highly intense light is made to incident on the metal surface. So due to the incident of the highly intense light, more and more number of photoelectrons will be ejected out from the metal surface. Are you clear? So the electron emission will be more when the intensity light is more. Are you clear? So the intensity is more, therefore the number of electrons emitted from the metal surface will also be more. So due to the emission of more number of electrons, the strength of the photoelectric current shown by the micrometer will also be more. Let us imagine the strength of the photoelectric current is 15 microampere. So the conclusion is, when the intensity is increased, when the intensity of the incident light is increased, the number of electrons emitted from the cathode, photosensitive cathode will also be more. Correspondingly, there will be a corresponding increase in the photoelectric current. Intensity of the incident light is more, photoelectric current also slowly increased. Are you clear? Both are directly proportional. Now the thing is, here if a single photon is made to incident on this, so they are all photon, light particles are all called photons. When a single photon, when it is made to incident on the metal surface, a single electron will be ejected out. For example, if 10 photons, when they are made to incident on the metal surface, means 10 electrons will be ejected out. A single photon, it is capable of liberating only one electron. That you should not forget. Are you clear? A single photon, when it is made to incident on the metal surface, a single, is it clear, photoelectron will be ejected out. So that is an important key point that you should not forget. So from the observation, it is clearly understood that when the intensity is increased, intensity of the incident light is increased, the photoelectric current also increases. So we are able to plot the graph now. When no light is made to incident on that, no photoelectron will be emitted. So if intensity is 0, photoelectric current will also be 0. Are you clear? When the intensity is increased, see that intensity 1, intensity 2, intensity 3, we can mark like this. So for those points, intensity 1, intensity 2, intensity 3, intensity 4, the markings are made here. Are you clear? Just we can take the intensity in terms of percentage also. Next you are going to observe one animation. There all the things are clearly explained with the help of the animation. Okay, so here just I have taken the intensity in terms of number. Are you clear? The correspondingly the values of the photoelectric current, from this data we can plot the value. For the first intensity, this one may be the photoelectric current. Which one? 2 microampere may be the photoelectric current. For the second intensity, 5 microampere is the current value. For the third intensity, 7 microampere is the value. If all the values are plotted one by one, if they are connected, you will get a straight line. Okay. If all the values are plotted, later you can connect all the lines. Clear? Finally, you are getting the straight line. Are you clear? So that straight line that shows that the graph is linear, and finally the conclusion is, when the intensity is increased, when the intensity of the incident radiation is increased, photoelectric current also increases. So that is a conclusion of the topic. Okay. So this is the first thing you have learnt, basically the link between the intensity of the incident light and photoelectric current. Okay. Now we are going to observe an animation. In this animation, we are going to see how the photoelectric current varies with respect to the intensity of the incident radiation on the photosensitive cathode. Here, on the photosensitive cathode, sodium metal is coated. Here one virtual torch light is given. With the help of the virtual torch light, we are able to make the violet light to emerge out from the torch light. You have to assume that the frequency of the incident light is not going to be altered. That is, violet light alone is going to made to incident on the photosensitive cathode. I am not going to vary the frequency of the incident light, but the intensity of the incident light is going to be altered. That could be observed in the animation. Here one small marking is there, arrowhead is there at the top. There the variation in the position of the marking when it is slowly increased in the intensity of the incident light can be altered. The correspondingly, you can observe the emission of the electron from the cathode. When the intensity is increased, slowly the number of electrons ejected out from the cathode will also be increased. That you can observe now. When the number of electrons emitted from the cathode is increased, they will reach the anode. Finally, they will constitute a current. That current is called photoelectric current, that can be measured by using the micrometer which is connected at the bottom. Here two arrowheads are shown. One is for representing the intensity of incident radiation. The another one is the micrometer. There also another arrowhead is shown in the name of photoelectric current. So when the intensity of the incident radiation is increased, you can observe the increase in the photoelectric current. Observe the animation. You can observe that when the intensity is increased, the number of electrons ejected out from the metal also will be increased. Correspondingly, the photoelectric current which is shown by the micrometer will also be increased. So here all the reading, that intensity that is measured in terms of percentage, the photoelectric current that is measured in terms of milliampere, both are tabulated here. The readings which are shown here in the animation all are tabulated. Later we'll see how the graph can be drawn. Here I'll start the animation, I'll click the animation. Now you observe how the variation happens. Here initially the percentage of incident light is now 13%. Look at the current value 0.018. Now the intensity of the incident light is increased to 27%, 29%. Correspondingly, you observe the photoelectric current because number of electrons emitted from the metal surface slowly increases. Look at the beam of light also. There, from the torch light, slowly the intensity of the violet light is increased. When the intensity of the violet light is increased slowly, what will happen? The number of electrons ejected out from the metal surface also increases. Now the intensity of light is 72%. Look at the number of electrons ejected out and see the corresponding reading in the millimeter. Now slowly it reaches 86% now. More number of electrons are ejected out, current value also more. Now the maximum amount of intensity of light is going to made to incident on the metal surface. Now the percentage of intensity is increased. Now it reaches slowly up to 100%. Maximum intensity of light is made to incident on the metal. Look at the maximum amount of current shown by the millimeter. Are you clear? Finally, the conclusion is when the intensity of the incident light is increased, the photoelectric current, that is photoelectrons emitted per second, also increases. Okay. The readings which are observed in the animation all are tabulated. The intensity of the incident light in percentage, that should be taken in x-axis, and the photoelectric current in milliampere must be taken in y-axis. With the help of the readings, we could draw a graph. If all values are plotted, after connecting the points, you will get a straight line. The straight line graph that shows that the photoelectric current is directly proportional to the intensity of the incident radiation. The meaning is, when the intensity of the incident radiation is increased, photoelectric current also increases. That is, number of photoelectrons emitted from the cathode per second also increases. It's a linear graph. It is evident that photoelectric current, that is number of electrons per second, is directly proportional to the intensity of the incident light.